Hey everybody, I hope you're all doing perfectly splendid. Hello sir, I saw a couple of your YouTube videos and I would love to see if you can help me with my phone. I currently have an iPhone XR and when I was leaving from the restaurant, I left the phone on top of the car and it fell onto the road and it got ran over. That is terrifying. I purchased a new shell, new screen, new battery, and I transferred all of the components to the new shell. I'm currently getting a no display and the phone gets really hot when I turn it on with the display attached, but upon disconnecting the display, it turns on fine when I plug it into the charger. I can hear the charge noise, and so is the third time a charm. This is going to be the third iPhone XR no image phone that I've recorded a video on, but I am willing to bet that the customer's right. I mean, look at this thing. This thing is absolutely destroyed. This is madness. It is just completely mutilated. So here is the new phone. Now I have got this sitting here hooked up, no battery. I have their screen assembly hooked up. We're going to go ahead and connect our DC power supply here because we really want to see what this thing is drawing from the battery rail. Okay, we have got our power supply set to 4.1 volts at 3.2 amps, and we're going to turn the power supply on. 10 milliamps of current, 0 milliamps. That is a very good sign. Now we're going to prompt this thing to boot. I'm going to sneak around here behind it and press the power button. We're drawing half an amp, 600, and instantly this thing is going to start heating up. So we're going to go ahead and turn the power supply off. Now we're going to do this same exact test, only we're going to do it without the screen assembly. So I'm going to slip in here and disconnect both of our display flex cables. Now I'm going to turn the power supply back on. And we're going to push the boot button in. 1, 2, 3. Boot. Oh, it still jumps straight to a half an amp. Straight to a half an amp without the display connected. I'm starting to think this is also not a no image phone. Okay, so now we have disconnected our two cables that are actually for the display. Now let's disconnect this front flex cable here. Alrighty then, let's turn the power supply on. We are going to press the button to boot in 1, 2, 3. Boot. 700 milliamps, 150. We are now getting a normal boot sequence. Okay. All right, I've got this thing switched around. I have got a known good screen assembly hooked up to this. So I just accidentally broke my last connector for testing this style of battery connector. So we're just going to do this one this way. 70 milliamps. 200 milliamps. 400 milliamps. This is a pretty normal boot sequence. However, with the display hooked up, it's not drawing an excessive amount of power that would be causing it to get hot. So what that means to me is that the customer's screen assembly actually has a short in the front flex cable somewhere, which is extremely common. But also, this board has an issue that's causing it to not produce an image. Yep. Charge connect tone. Definitely a no image issue. So now we've got the board out of this thing. It just looks like a pretty standard iPhone XR board. You know, given the condition of the housing, I'm very surprised that this board does not have more damage. This doesn't look too bad. So looking at the board view for the iPhone XR, we can see that we have two display connectors. One of these is going to be for touch, the other one's going to be for image. It's really easy to recognize which display connector is going to be for image because they always come along with these image chokes. So I always like to go for image power first. This line here, this is 1V8 display, DVD con. These lines here on the XR, this is where our power line starts. So I've added a new piece of equipment to the shop. I've added a ocular. This is a microscope eyepiece that has like a built-in display, and that is actually hooked up Bluetooth to my meter. I was a beta tester for this, and I've wound up really loving it. So if you're interested in this, the link is in the description below. So the first line I'm going to check is PP1V8 display DVD con. With our red probe on ground, our black probe on the active line, we're getting a 0.31. That is a normal reading. The next pin down, we are getting a 0.009. That is actually, you can't see what I'm doing. That is actually a dead short. First we checked this pin here. We got a 0.31. And then this pin here, we're getting a 0.009. So, hey, right off the bat, we're coming up with a short within the image power circuit, right? What line is that? The second pin down. That line is actually PP5V7 display AV-DDH con. So that is absolutely, positively not supposed to be a direct short to ground. So where does that actually go? So we can see it goes right to a capacitor here, right next to the connector. Let's zoom right on out. I'm not seeing anything on this side of the board. Let's check side B here. Ooh. We've got some components right down here by NAND. We've got this here, which is going to be a cap, but this here, this is a filter. So either we have a short to ground on this side of the filter, or we have a short to ground on this side of that filter. Now, judging by what all we have available here, we've got some pretty large caps. We've got 1, 2, 3 decent sized caps that are all on that line. Judging by what the housing looks like, do you think there's a pretty good chance we might have shattered one of them caps on the back of the board? I don't know, let's see. So to get to that spot, we got to go through this sticker because those components are right next to NAND, and NAND is right here. And this time we're going to leave some of that adhesive on the board. I'm not planning on working on this too much face down. Here we are looking at the bottom of the board. We had a small inductor here. No, that's a cap. Maybe I'm digging in the wrong spot. Okay, so we have a small inductor down here. Our filter is actually down in here. And if the short is on the connector, on the display connector side of this filter, then this filter should be blown. That filter looks perfectly fine. So I'm more inclined to think that the short is going to be on the powered side of that filter. So we're going to go after the most obvious components. We're going to have a look at these caps here. Okay, those caps visually look okay. Now, also on our board view, it could also be over here. It could actually be C5502. Let's have a look at C5502. Okay, C5502 also looks visibly fine. Let's just verify that our board view is correct. You know, I have ran into some mislabeled lines and things. So at C5502, we're getting a 0.009. So we're definitely barking up the right tree here. We have a short on one of these 5-volt power lines, and from experience, we know that it's most likely going to be one of these ceramic caps, but how do we tell exactly which one it is? First, I'm going to connect us a little ground clampy clamp here. We'll just clamp right on there. I like choosing that spot on the 10R because we got a nice firm shield on both sides. It can take it. We're going to set our power supply now. I'm going to go ahead and roll this thing down to 1 volt because really for short detection, you really want to use as little as possible. All right, so we'll just let it have all the amperage in the world. So for this next little step here, we're going to be using the C Compact Pro with the macro lens. This is actually my go-to thermal camera, my favorite camera for doing this type of troubleshooting. All right, we're going to allow current to flow through this line at 1 volt of potential here, and let's see what we get. We're drawing a 1/4 amp. Whoop, did you see this? So as soon as I apply power here, the power supply jumps to 200 milliamps. And we instantly start getting a hot spot right over here to the left side of NAND. So now what we've done, we have narrowed this down. We now know that we have 3 caps here on that line. We applied power over here, and when we did that, it caused one of these 2 caps over here to get hot. So we will put some alcohol here and connect our power and see which one sizzles. Okay, and since nothing sizzled, because the thermal camera is far more sensitive than I am, we're going to go ahead and turn up our voltage. This line is normally set to handle 5 volts, so I'm going to go ahead and crank this up to 4 volts, and we'll do the same thing. And see who, let's see who sizzles. Oh, yes. It was actually the filter that sizzled. I'm going to go ahead and crank this up to 4 volts. What we've just discovered here is that this problem is actually not with any of these larger caps. And if I wasn't so caught up in the moment here of creating this video, I would have checked to see which side made that filter get hot, but I sort of skipped that step. So now we know for sure. This cap here is the one that's shorted. And since that is on the yonder side of this filter blew as well. Honestly, the filter probably needed replaced anyways, but I just smoked it. I'm just glad I don't have to remove that bottom shield today. I'm going to start chunking away at this thing because it is going to need a brand spanking new capacitor and a brand spanking new filter. Okay, let's see if we can get that burnt little filter out of there without without damaging anything. I'm actually worried about the pad that it sits on. I don't feel like running any micro jumpers, and if I can get away with just soldering something on here, that is by God what I'm going to do. So we're going to get down in here with our micro pencil. This is the Hacko FM 2032 with the 0.1 millimeter conical tip. Links in the description. Okay, looks like we got at least a pad on one side. What do you think the odds are of also having a pad on the other side? Okay, so we do actually have a pad on both sides. This is going to be a straightforward repair. All right, let's get rid of the cap that started all this trouble. That's this little cap down in here. So we're going to flood this with some leaded solder. I'm going to stick my micro pencil on one end of it and sort of pluck it off the board. Little hot air, little micro pencil. There we go. And I did it that way to keep from floating NAND. We're trying to use as little heat as possible because we actually want this board to work when it leaves here. We got some pads fluffed up for the cap. No luck fluffing down in there yet. Let's clean this up a little better. All right, let's get it fluffed up and ready to receive some new components, and then this will be a happy board at least. Next, we need us a brand spanking new capacitor. There we go. So that capacitor is going to sit just down in there just like that. And because I'm feeling maybe somewhat lazy today, maybe somewhat not wanting to get down in there with my micro pencil, I'm just going to go ahead and solder this thing down with hot air today. So I have 6337 leaded solder here on the pads, which is going to enable this component to float into place before everything else around it melts. There we go. Now, as this cap warms up, it's going to want to shimmy into place, I hope. Okay, I see the leaded starting to melt. There's one side. And then there's the other. Now we're also going to need us a brand spanking new inductor because remember we pretty well caught the one that was in there on fire. There we go. Let's get us a little bit of flux down in there, being very careful not to touch the filter with it or it'll suck up on the syringe. All right, so let's go ahead and start warming this up. Marvelous. We'll clean this up and make it look pretty. Do a couple of checks here and then we'll see if it works. So real quickly here, I just want to check and make sure we've got a good reading on this pin that was a direct short to ground. That pin is now reading a 0.60, and before we were getting more like a 0.00. So we're going to go with the customer's screen. We're going to go with my battery because I know this battery's charged. I know it's an iPhone 10 battery, but we'll be okay, right? Okay, fellers, we're going to press the button to boot. And 1, 2, 3. Sorry, no power supply because we're on battery, but I pretty well guarantee we're going to get an image. Woo woo, we got an image! Oh, look, and the customer has a damaged screen. All right, we're going to go ahead and let this thing boot up. Yeah, we have working image. We have working touch. I'm not going to turn the brightness up far enough so you can see it because then I don't have to blur it. I'm going to clean this up a little bit more and then put some UV mask on it. This guy is really, really good with doing his own repairs. So what I'm going to be doing on this one is calling an Intuit at the logic board repair. I'm going to let him handle the screen assembly and the front flex cable. So guys, that is going to be the end of this video. I really thank you all for watching and I will see you soon. Have a good day.